Hello everybody. Again I am here with you for the another property of the logic gates, and basically we are looking for the NAND gate and the NOR gate. Now the today we will see the universal property of the NAND gate, how this NAND gate is called as a universal building block. Already NAND gate is nothing but to be, it is a combination of AND plus NOT is to be there, and how this NAND gate is having the properties related with the universal building block, we can see. Basically it is called to be as an universal building block, or it is because of NAND gate can be used as a NOT gate, as a OR gate, as a AND gate, and as a NOR, NOR gate also, and that's why it is called as a universal building block. And let's see how this NAND gate can be used as a NOT gate. Now here is this NAND gate is made in such a way, the circuit is made in such a way that it can be used as a NOT gate. Now this NOT gate, generally we are aware about that it is a complementary gate, and it gives you the whatever be the input is to be there, it is inverted output it gives. And now let's see how this NAND gate can be work as a NOT gate. So for this case, here is the one NAND gate in this diagram. If you look at this two inputs are going to be shorted, and it is become as a one input, and the output will be same in that case. This is what the symbolical representation of this NAND gate. And in this case, if suppose I am giving any input for this NAND gate, or that is to be A will be 0, in that case here it is both the inputs will be 0 0. And as we are aware about that, when the both the inputs are 0 0, the NAND gate gives you the condition, that is when the both the inputs are to be as n 0 0. Look at this case where it is to be as n 0 0, it gives you output to be as n 1. That means when A is going to be 0, it is giving you the output to be 1. So what will happen for the another case when this is to be as an condition, that is A, when A is to be there, here it is to be as an input is given to be as an 1. When it is become 1, both A and B will be 1 1. So when the 1 1 input is to be there, what will be the output for in this case? So look at this NAND gate condition, where we have to know that this is what the condition where the 1 1 input is given, it gives you output to be as an 0. As we are aware about that, this NAND gate is having the truth table for the two inputs like this. Then with this case, when the 1 1 input is to be there, that means it gives you the complement, that is 0 is to be there. That means when input A is 1 is to be there, the output will be 0. If you look at this NAND gate, it is working as good as your NOT gate. And here this circuit is nothing but to be as the simply NOT gate from the NAND gate is to be there. And in this case, this NAND gate can be used as a NOT gate. And another part where as we are aware about this NAND gate truth table, that is it is completely complement of the AND gate. And as we know, the AND gate is to be having the logic when all the inputs are high, output is to be high. But for the NAND gate, the logic is to be behind this NAND gate is to be there. When all the inputs are high, the output is 0. So this is what the logic. With this logic, we have seen that how the NAND gate is made from the NOT gate is to be made from the NAND gate. Now let's see how this AND gate is to be made from the NAND gate. It is very simple, that AND plus NOT, it gives you NAND. And again, when you are you are using one another NOT gate in front of the NAND gate, it will give you original, that is the AND gate. That means complement of the complement, it is what the original value is to be there. So here is this circuitry diagram. Here the two NAND gates are going to be used. In this case the first NAND gate output is given to the another second NAND gate, and the second NAND gate inputs are going to be shorted. So in this case, how it this circuitry works as an we can say as an AND gate, where we can say these two NAND gates will gives us output as a AND gate. So let's see for the first condition, that is if suppose A is to be 0 and B is also to be 0. As we know, for the NAND gate, when the 0 0 condition is to be there, In that case we have, when the 0 0 input is to be there, this is the truth table for the NAND gate, it gives you output to be as an 1, here it is to be there. So in this case, when we have for the first NAND gate, what is going to be happening, when the 0 0 is to be given for this first NAND gate, the output for this first NAND gate will be 1, but this 1 input is given to the second NAND gate. So the gate number 2 or the NAND gate 2 is having the input 1 1, and whatever be the output of the first gate, that will be input for the second gate. And as the 0 0 for the first NAND gate output is 1, and that 1 output is given to the second NAND gate, and that will be input for the second NAND gate, and definitely 1 1 will be the input. And in that situation we know, for the NAND gate, when the 1 1 input is given, the output will be 0. So here it is to be there, that means it will give you the output to be as an 0. That means what we have taken, for the A it was 0, for the B it was 0, and what we have, the result is 0. So if you look at the AND gate truth table, the 0 0 input, for the 0 0 input the output will be 0. Again let's see for the second condition, that is 0 1, A is to be 0 and the B is to be 1. In that case what will happen for this circuitry? So if suppose this A is going to be 0 and B is to be 1, so in that case, for the NAND gate 0 1 condition, for the first gate, what will be the output? Definitely for the 0 1 condition we know that the output is 1, and in this case when the output is going to be 1, definitely this output of the first gate will be, the output of this first gate 1 will be input for the second gate, and when the 1 1 input is to be there, output will be 0. So in that case, for the 0 1, the output is also becoming to be as an 0 with this circuitry. If we make it reverse, that is the vice versa condition, that is 0 1 we have taken, and if suppose instead of that we have taken 1 0, the same result will be there for the 1 0. Similarly this first NAND gate will give output as a 1, and that will be input for the second gate, and as the NAND gate is having 1 1 input, it gives you output 0. So that is what it is clear, for the 0 1 and the 1 0, the output will be 0. It is as good as similar to the what we have seen for the AND gate is to be there, that is 0 1 it is 0, or 1 0 it is 0. Now let's see what happens for the last case, that is to be as an 1 1 is to be there. Suppose this NAND gate is first NAND gate is given input as a 1 1. So in that case this A is 1 and this B is 1. So in this case, when for the first NAND gate, for the NAND gate, when the 1 1 input is to be there, definitely it is having the output 0 for the NAND gate according to the truth table for the NAND gate. And when the 0 is the output for the first gate, that will be input for the second gate. That means for the second gate input is 0 0, and as we know, for the NAND gate, when the 0 0 is the input, output will be 1. That means it is clear that when the input is given to be as an 1 1, the output is giving us for this circuitry, that is 1. If you look at for the all the conditions, that is for the 0 0 it is giving us 0 0 1, it is giving 0 1 0, it is giving 0, for 1 1 it is giving 1. So this circuitry gives output similar to the AND gate, and that's why this is called to be as an AND gate from the NAND gate is to be there. So this is what the simple case where this AND gate can be used as a AND gate can be made from the NAND gate. Now let's see how this NAND gate can be used as a OR gate. So this is what the another circuitry for this making the OR gate from the NAND gate. We are using here the three gates are to be there, three NAND gates are to be used here. And in this case, if you look at the first NAND gate is to be shorted, second NAND gate is also going to be shorted, and the output of this both the shorted NAND gates is given to the another NAND gate, that is third is to be there. So in this case, how this circuitry works as an OR gate, let's see. If suppose the same, when the two inputs are there, probabilities of the inputs are 4, 0 0 0 1 1 0 and 1 1 is to be there. So let's see how this either it gives you result equivalent to the OR gate. So this is how the for the OR gate, let's see. If suppose A is going to be 0 and the B is going to be 0, when the A is going to be 0, this first gate, first NAND gate, it will get 0 0 as an input, and we know as for the NAND gate 0 0 is the input, it will give you output as a 1. And similarly for the B, it is also having suppose condition 0, then definitely for the second gate the input will be definitely to be as good as 0 0 is the input is to be there, and as for the NAND gate, when the 0 0 is the input, output will be 1. If you look at this case in this truth table, you will find it clear that for the 0 0 input for the NAND gate, this is what the 0 0 input. For the 0 0 input, NAND gate gives you output to be as an 1. So first gate which is to be shorted and the second gate which is also to be shorted, it will give us output as a 1 1. From the first gate we have the output 1, and from the B or the second gate we have the output 1, but this output is given to the third gate as input. So the input for the gate NAND gate 3 will be 1 1, and as for the any NAND gate, when the input is 1 1, it is gives you output to be as an 0. So this is how for the condition 0 0 we are getting output as a 0, which is to be similar in this gate as an for the OR gate truth table. If you look at, as we know that for the OR gate, that OR gate is nothing but to be when the any of the input is high, output is going to be high. And here in this first case we have seen for the 0 0 we are getting the same output as a 0. Now let's see for the another case where the another condition is to be taken into account for the same circuitry, that is now A will be 0 and B will be 1. And in this case for the first NAND gate, what will happen, it will take 0 0 as a 1 input, and as we know for the any NAND gate, when the 0 0 is the input, it will give 1 as a output. And as for the second NAND gate, that is B, which is going to be shorted, definitely for the second gate the input is 1 1, and the 1 1 input is to be there for the any NAND gate, it gives us to be as an output 0. And but whatever be the output from this first gate and the second gate, both are the NAND gate, these both the outputs are given to the third NAND gate, and here the input for the third NAND gate is 1 0. And as we know for the such condition, that is 1 0, the NAND gate will gives you output to be as an 1 is to be there. That means clearly here if you look at this case where it is to be clearly mentioned 0 1, the output will be 1. So the final gate, that is the gate number 3, what it will give us as an output, it will give as a output 1, but for which condition, when A is going to be 0 and B is to be 1. So if you look at this OR gate truth table for the 0 1 condition, if you look at this case, it is similarly showing same thing. That means to be for the 0 1 condition we are getting the output 1. If we make this reverse condition, that is 1 0, it will give us the same output will be there 1. So let's see what happens for the last case, that is 1 1 input is given in that case. If suppose the 1 1 input is given for the both the gates, or the gate number 1 and this gate number 2, and A, that means to be for the gate number 1, 0 1 1 input will definitely gives us output as a 0, and for the second gate, second NAND gate, the 1 input, that means to be 1 1 input is to be there, and that will gives us output to be as a 0. Both the outputs from the first gate and the second gate will be input for the third NAND gate, and definitely for the third NAND gate the input is 0 0. And as we know that for the 0 0 condition, the NAND gate will gives us output to be as a 1 is to be there. That means when the input we have given 1 1, the output we are getting here to be as an 1, which is again similar to this OR gate truth table. That means for the 1 1 condition we have the output 1. So this circuitry, which is completely made from the NAND gate, which is giving us the output similar to the OR gate, and that's why we can say this circuitry is nothing but to be as good as your OR gate is to be there. And here how this NAND gate can be used as a OR gate, that we have seen. Now again, the NOR gate from the NAND gate. Similarly, which is to be as good as here, if you look at this same case, we are using the same circuit we will use. Only what we have to do, only we have to use one another NOT gate that will give us a NOR gate output is to be there. Because why? This circuitry gives us output for the OR gate, and we know OR gate plus NOT gate, it gives you NOR gate is to be there. So we just need to add one NOT gate in front of this your circuitry, which is used from the NAND gate. And again we have to use this NOT gate from the NAND gate. How it is to be made up of? Let's see. This is what the case where we are using the four NAND gates are to be there. This is 1, 2, 3 and 4 is to be there. So this is how these four NAND gates are going to be used. So let's see the first condition, where it is going to be giving you as an 0 0 is the condition. When the 0 0 is the input, definitely this first gate and the second gate, for the first gate 0 0 input, that will gives us output 1, and for this second gate 0 0 input, it will gives you output 1. But for the third gate the input is 1 1, and that will definitely gives us output to be as an 0. But this 0, which is to be output of the third gate, which is input for the fourth gate. And what we have for the fourth gate? For the fourth gate we have input as a 0 0, and for any gate, or sorry, any NAND gate, when the input is 0 0, definitely output is 1. And if you look at this case where the 0 0 input is given, and what we are getting? We are getting output as a 1. So if you look at the NOR gate, the NOR gate is also having the same condition. For the 0 0 we have the output as a 1, which is similar to this NOR gate. The circuitry giving you the same output what exactly the NOR gate is having. Let's see the another condition, that is 0 1. And in this case what happens for the same circuitry? Now the 0 1 condition is supposed to be given for this case, that is to be for the first gate it is 0, and for the second gate it is 1. Definitely this first gate, when the 0 0 input is there, the output will be 1, and for the second gate the 1 1 condition is to be there. It will gives you NAND gate will gives you output to be as in 0. But which will be the output from the first and the second gate will be input for the third NAND gate, and 1 0 condition for the any NAND gate, it will gives you, if you look at this case where the for the third gate it is having the input that is 1 0, and for the 1 0 condition we know that the output for the NAND gate will be 1, and definitely the 1 output for the third gate will be input for the fourth NAND gate. And when 1 1 condition is to be there for the any NAND gate, it will gives you output to be as an 0. So if you look at this case where the 0 1 condition, 0 1 condition for this circuitry, it gives you output similar to the NAND gate. If we make it vice versa, that is 1 0 condition, it will give you same output, that is the 1 0 will be definitely 0 will be there, same action will take place, only instead of that 1 0 output for the here in this case for the third case where it is to be as an 1 0, if we are looking for, that is this is the third case is to be there 1 0. Here what we'll get, that for this 1 0 the first gate will have the input 1, and definitely the input will be 1 1. For the first gate it will gives you output 0, For the second gate, input is to be 0, that is 0 0 input is for the second gate, and it will give you output 1, and 0 1 condition for the third gate will gives you output to be as an 1, and the 1 1 input will be definitely again gives you output to be as an 0. Now looking for the last case where the input is 1 1, that means the A is 1 and the B is also going to be 1, but this A is 1 here, the gate number 1 is to be shorted, and due to that the 1 1 input will be there for the first NAND gate. And as we know, for the any NAND gate, when the 1 1 input is there, the output will be 0. The same thing is going to be happening for the second NAND gate, and in input 1 1 will definitely gives you output as an 0. But what is that, the second and the first gate output will be input for the third NAND gate, and 0 0 input for the any NAND gate will gives you output to be as an 1, and that will be definitely for the 1 1 will be this output of this third gate will be input for the fourth NAND gate, and 1 1 will be there for the fourth NAND gate. And as we know that for the any NAND gate, when the input is 1 1, the output is definitely 0. So what is happening for the 1 1 condition, we are getting the 0 output, and this is what the case where the last if you see this NOR gate results are to be there 1 1, it is also giving you the similarly 0 output. So if you look at, we have seen for the all the conditions, our circuitry which is made from the NAND gate, 4 NAND gates, giving us output similar to the NOR gate, which is having the 0 0 1 0 1 0 1 0 0 and 1 1 0 is to be there, which is similar to the NOR gate is to be there, and that's why we can say NOR gate from the NAND gate is to be there. If you look at all these conditions or all these gates, that is what we made from the AND gate, we made OR gate, we made NOT gate, we made NOR gate, and all these gates which is made completely from the NAND gate. And using this NAND gate, we can make NOT gate, AND gate, OR gate, NOR gate, and that's why the NAND gate is called as a universal building block. And this is all about the what to be as a NAND gate is to be there. Thank you for joining this session. Be at home and be safe. Thank you.